Hey, this is Mr. Molo for lesson 3-4, graphing linear equations in standard form. All right, so we're going to pretty much kick off our graphing thing today. So lots of graphing going on over the next couple of days, and this one's going to be just one way to graph, and it's called in standard form. So let's kind of look at a problem here before we start graphing and see why the graph looks like it does. So you sold a total of $16 worth of tickets for a fundraiser. You lost track of how many types of tickets you sold. Adult tickets were $4 each, and children tickets were $2 each. So I know that it's $4 for an adult ticket, but I don't know how many tickets I sold. And I know it's $2 for a child's ticket, but I don't know how many tickets I sold. And we know that we sold $16 worth. Okay, so we'll call this X and this Y. Okay, so we just did that. All right, B, so let's find a table to show how many tickets we could have sold. Okay, so let's pretend that we sold 0 adult tickets. Okay, so if I sold 0 adult tickets, that means I would have had to sell all child tickets. And if child tickets are $2 each and I sold $16 worth, that means I'm selling 8 child tickets. So 2 times 8 is 16. Okay, let's pretend I sold 1 adult ticket. So now I'm at 1 adult ticket is $4, and I still need to get to 16. So that means I'm missing $12 there. So if I'm missing $12, I would need to sell 6 child tickets, because 6 times 2 is 12. Same thing, let's pretend I sold 2 adult tickets. So 2 times 4 is $8, but remember I still need to get to 16, so I still need another $8. So for me to get to $8 by selling child's tickets that are $2 each, I would need to sell 4 children's tickets. Okay, I can still sell 3 adult tickets. 3 times 4 is $12. I still need to get 16, so I need to sell another 2 children's tickets. Let's pretend I sold 4 adult tickets. 4 times 4 is 16. I'm already at $16, so that means I sold 0 children's tickets. So this is our possible kind of range here. I could have sold anywhere from 0 to 4 adult tickets, and I could have sold 8, 6, 4, 2, or 0 children's tickets. Doesn't really make sense logically for me to sell 1 child's ticket, because that means I would need to have $14, and 4 doesn't go into 14, so I know that didn't happen. So these are kind of my possible scenarios there, just kind of going through it. So now if I kind of graph this, so I have X as 0 and Y as 8. And then here I have X as 1 and Y as 6. Here I have X as 2 and Y as 4. X is 3 and Y is 2. And X is 4 and Y is 0. So those are my possible combinations there for how I could have sold the number of tickets. So we just graphed the line 4x plus 2y equals 16. Okay, so $4 for children's tickets. We don't know how many we sold. Plus $2 for adult tickets. $2 for children's tickets. We don't know how many we sold. So y, and we knew we sold $16 worth. Okay, so there's our graph using intercepts. Okay, let's look at another one that pretty much just has the problem, none of the words for it. Okay, oops. So y equals -3. So kind of important to know when it just says y equals and x equals, so that's why we're looking at problems like this. So if it's y equals -3, well, y equals -3 right there. Y also equals -3 anywhere else on this line. So when you have something that says y equals, you're going to get a horizontal line then. If you have something that x equals, like x equals 2 everywhere on this line. So then you're going to end up with a vertical line there. So y equals, we end up with a horizontal line. X equals, we end up with a vertical line. Okay, and let's go back and talk about intercepts for a second before. So we're pretty much finding our x-intercept and our y-intercept, and then kind of just connecting the 2 dots there. So x-intercept, if you remember, that's when your when your graph crosses your x line. Y-intercept is the other one where that line crosses your y line. And it says here, kind of gives us a hint. When we're finding the x-intercept, we make y equals 0. And then the other way around, when we find the y-intercept, we're making x equals 0. I'll kind of show you what that means on 3, 4, and 5 when we look at these problems here. So 3x plus 4y equals 12. So let's pretend we're finding the x-intercept. So I'm going to make y equals 0. And when I say that, I mean I'm literally going to take the y out. So then I end up with 3x equals 12. I'm going to divide each side by 3, divide each side by 3. So I find out my x-intercept is 4. Now let's find out the y-intercept. So to find the y-intercept, I'm going to get rid of my x. So I'm going to make my x equal 0. It pretty much goes away. So I end up with 4y equals 12. Divide both sides by 4, divide both sides by 4. My y-intercept is 3. So I plot those 2 points on a graph, my x-intercept being 4, my y-intercept being 3, and I would connect the dots then. So look at this one, has some negatives in there. So same thing, let's find my x-intercept first. So I'm going to get rid of this y here. So I end up with negative x equals 16. We don't want negative x, we want positive x. So I'm going to divide by negative 1. Negative 1. So I end up with x equals a negative 16. So there's my x-intercept. And then now to find the y-intercept, same thing as before. I'm going to get rid of the x. So I'm left with negative 4y equals 16. Divide both sides by negative 4. So y equals negative 16 divided by negative 4 is a negative 4. Okay, let's look at a couple more here. So let's look at 6 and 7 now that we actually have to graph these. Okay, so now it says use the intercepts to graph the linear equations and then label the points. So same thing, nothing changed, except now we're actually going to graph this one when we're done. So I have negative 8x plus 12y equals 24. So I'm going to get rid of my 12y, put in a 0. 12 times 0 is 0. So I'm left with negative 8x equals 24. Divide both sides by negative 8x. I'm sorry, negative 8. And I figure out that x equals a negative 3. So I'm going to put a dot when my x-intercept is negative 3. And then here I'm trying to find the y-intercept now. So I'm going to get rid of that negative 8x. And so I got 12y equals 24. Divide both sides by 12. Divide both sides by 12. 24 divided by 12 is 2. So I figure out my y-intercept is 2. So when I graph that line right there, that's my graph for that line. Okay, let's look at number 7. Same thing. I'm going to find my x-intercept first. So get rid of the y. So 2x equals 4. Divide both sides by 2. I figure out 4 divided by 2 is 2. Same thing. I'm going to get rid of my x and figure out y. And this is a nice one because it already tells us y equals 4. So my x-intercept is 2, so I'm going to put a dot at 2. My y-intercept is 4. I'm going to put a dot at 4, and then connect the dots. All right, let's look at this other word problem, kind of similar to the one we did before. So the school board is selling sweatshirts and baseball caps to raise $9,000. Okay, a little different than the $16 one that we just looked at, but $9,000. Okay, sweatshirts cost $25 each. Baseball caps cost $10 each. So they gave us the equation this time, which is nice. So 25x equals 10y equals 9,000. That models the situation. X is sweatshirts, y is baseball caps. All right, so let's find the intercept. So let's find the maximum number of sweatshirts that were sold and the maximum number of baseball caps that were sold. And we know the answer is probably somewhere in the middle. Like you didn't probably all sell all baseball caps or all sweatshirts. You probably sold a mixture of both. So if I have 25x plus 10y equals 9,000. Okay, let's find the max number of sweatshirts I can sell first. So I'm going to get rid of that 10y. So I'm going to do 25x equals 9,000. Divide each side by 25, divide each side by 25, and I figure out my x-intercept is 360. So my x-intercept is 360. So I could have sold possibly, not likely, 360 sweatshirts, and that could have given me, and that gave me the 9,000. Okay, now let's figure out the y-intercept. So 10y equals 9,000. Divide both sides by 10, and here's the 900 I talked about earlier. So y equals 900. So I could have also sold only baseball caps, and I would have had to sell 900 baseball caps then to get to my $9,000. Again, very unlikely that I just sold all of one thing and zero of another. So this next problem says, if 258 sweatshirts are sold, how many baseball caps were sold? Okay, so somewhere in the middle, not just all of one. So I know sweatshirts are $25 each, so I'm going to replace that 258 with the x. So x is gone, I'm going to put the 258 there, plus 10y equals 9,000. Once I multiply 258 times 25, that means I sold $6,450 worth of sweatshirts. So 6,450 plus 10y, I still don't know how many baseball caps I sold, equals 9,000. So now let's subtract that 6,450 minus 6,450. I end up with 10y equals 2,550. Divide each side by 10. Divide each side by 10. And I figure out that that means I would have sold 255 hats. Or baseball caps, I'm sorry. So if I had sold 258 sweatshirts and 255 baseball caps, that would get me to the $9,000 that I made. It wants us to graph it. It's kind of weird because there's no numbers here, so we're just going to kind of make it up, and we'll go that these are hundreds each. So 100, 200, 300, 400, 500, 600, 700, 800, 900. So we'll say that that's 900, and we'll call this the baseball cap sides, not hats. So I could have sold 900 caps and 0 sweatshirts, or I could go the other way, and let's do this by hundreds as well. So here's 100, 200, 300, 400, and I could have sold 360, so like almost right in the middle there. So somewhere on this line is my answer of how many baseball caps and or sweatshirts I sold to make sure that I got to my $9,000.